Hey everybody, I hope all is well. So I've chosen the boring old regular video for this intro because this is going to be a boring old video. No, I'm just kidding. Would I ever bore you? Would I ever bore you? Don't answer that question. Do not answer that question. Oh no, look, it's not boring. There's different colors. So this video is going to be about research questions and setting up hypotheses. This is the first video for section 2 of the course, which is all about hypothesis testing, which may or may not be the coolest thing in the world. So what we're going to do at the beginning of this section is talk about simple hypothesis testing. And let's just first go over some of the types of questions we might ask for a simple hypothesis test, because the very first thing you're going to do in any type of hypothesis test is ask a research question. Number 1 right there, research question. So I'm going to do 3 different examples of research questions. The first one, is the true average return of Amazon stock greater than 5% per year? So if you're a stock analyst or just an investor, you might care about such a question. Maybe you have a different opportunity to invest in something that you're pretty sure will be 5% return per year. Well, then you'd want to compare any other potential investment to that. Maybe Amazon stock is one of those comparisons you'd like to make. So it's a totally reasonable question. You might want to know, is the true average return of Amazon stock greater than 5% per year? So that's question number 1 that we're going to work on, or question A, I've labeled it. Question B, is the total cost of going to Weber State less than $7,000 per year? So for example, maybe a student has an opportunity to go to some other school and they've been told, hey, if you pay us $7,000 a year, that will be all in. You will have to not pay any money beyond that. So maybe that's room and board, books, everything is $7,000. Well, then you maybe can take a sample of other students that go to Weber State, find a sample average, and then answer this hypothesis question, or this research question using a hypothesis test. Those total costs probably vary from student to student, right? Because maybe some students have to drive farther to get to school. Maybe some students get different types of scholarships. So it might vary randomly from student to student. So you need to take a sample to say, well, on average, is it less than this $7,000 opportunity? So that's question B. Question C, are the true average returns from a diversified stock portfolio different than 4%? So this is another example of a research question you might ask. Maybe you have the opportunity to buy a bond fund that is guaranteed to earn 4% over 10 years. Well, the opportunity cost of investing in that bond fund might be investing in a diversified stock portfolio. So you might want to take a random sample of diversified stock portfolios and ask how much are they returning per year to compare them to that 4%. So another kind of real-world potential research question we could ask. One thing that I want you to notice about these 3 questions and the nature of simple hypothesis testing, this first thing we're going to do, is that all of these questions offer a baseline number. So the first question we're comparing to 5%. The second question we're comparing to $7,000. The third question we're comparing to 4%. So each of these questions give us a baseline for our comparison. Later on in section 2, we're going to move away from that, but that's what simple hypothesis testing is going to be. Is let's compare to a baseline given number that's implied by the research question itself. So in those, again, here's our baseline for question 1 is 5%. For the second one is $7,000, and for the third one is 4%. The other key thing that we're going to look for in these questions is kind of a key word about the direction. That keyword in the first question is going to be greater than. We're giving our question direction. Is it greater than? And that's going to be important. The second one, less than. That's going to be important when we set up our hypotheses in the next step. Third one, different than. Those are all kind of different by nature, right? Greater than, less than, or different than. And that's going to guide how we do step 2 of any hypothesis test, is going to be setting up the hypotheses. Now, so for any hypothesis test, there's what's called a null hypothesis. That's going to be labeled H with a little 0, and you say that H naught, and that means the null hypothesis. And alternative hypothesis. So there's always 2 in any hypothesis test. That's going to be labeled HA for the alternative hypothesis. Now, the way that you should think about these is the way I've written these questions. This isn't always true, but the way that I write them makes it true. So notice that, is it greater than? So if the answer to the research question is no, then the null hypothesis, H naught, is true. So if we go do our analysis and decide no, the answer to A is no, that Amazon stock is not greater than 5% per year, that would be the null hypothesis is true. Now, if the alternative hypothesis is true, then I'm going to say it the opposite way to be consistent. If the answer to the research question is yes, then the alternative hypothesis is true. So these are opposite situations. The null hypothesis and the alternative hypothesis characterize different or opposite situations. And basically what setting up hypotheses is writing these ideas down, but in mathematical notation. So let's do A. Let's set up our hypotheses for question A. So the first thing I do is I just write H naught and HA. And then these hypotheses in mathematical terms will follow. And another thing that I always do is I define what mu is. I'm asking a question about a true population average. Mu for the first question is going to be true average Amazon returns, right? Because that is the quantity we're asking about in the question. Is the true return of Amazon stock greater than 5%? So I want to define my mu right there just to make my life easier so that later on in my hypothesis testing steps, when I see mu, I'm reminded right at the beginning of what mu is actually. And in this case, for question A, it will be true average Amazon returns. Now the null hypothesis will be true if the answer to this question is no. So how could that be no? Well, if mu, which we just defined, if the true average returns are less than or equal to 5%, which also notice could be written 0.05, because that's just another way of writing 5%, then the answer to that question is no. And what did we say right here? If the answer to the research question is no, then the null hypothesis is true. If the answer to that question is no, then boom, right there. Mu is less than or equal to 5%. That question has a no answer in that case. Now the alternative hypothesis is the opposite. Mu is greater than 5%. Because if that were true, then the answer is yes, right? That says the true average stock returns from Amazon are greater than 5%. So it's pretty straightforward. You just have to be careful and always remember to kind of check yourself based on these two criteria. But other than that, it's pretty straightforward. Another thing I'm going to point out here is we often refer to, and we'll use a lot, mu naught. What mu naught designates is what I like to call the cutoff point between, let's just say between HO and HA. In this case, in this problem, mu naught is equal to 5% or 0.05, because that is the number that divides these two hypotheses, right? Because if you're greater than that number, you're in the alternative hypothesis world. If you're less than or equal to that number, you're in the null hypothesis world. Another thing that's good to point out, the null hypothesis always includes equality. So that's why I drew this little line for less than or equal to. That always is in the null hypothesis. We can't put that also in the alternative hypothesis because that would cause a problem. That would lead to overlap. Both of them would be true at the same time if I put this line right here. But we do not want to do that. We should never have equality in the alternative because we always have equality in the null hypothesis. But these are our hypotheses for that research question. So now let's try B. In that question, mu is going to be true Weber state tuition because that's the quantity we're asking about. So mu equals true population. I kind of bounce back and forth be saying true average and population average. Those mean the same thing. True population, maybe, and also between mean and average. Those mean the same thing, as you know, right? True population mean Weber state total cost, actually. Total cost. So we've defined our mu. The next thing is to say HO, the null hypothesis, HA, the alternative hypothesis. Then we can write mu. So these steps are pretty straightforward. Is do what's easy first. So I'm doing all the easy stuff. I know that I'm gonna have to write these in this way. Now I have to think a little bit because when will the alternative and null hypothesis be true? Well, now we've flipped to less than. That's why that's a key word here. Last time we were doing greater than. So the answer to this question will be no if mu is greater than or equal to 4%. Or sorry, that's from the next question. 7,000, right? Because we're using a 7,000 is our cutoff point in this problem. So if Weber state tuition true average is greater than or equal to $7,000, the answer to this question is no. So now we have mu greater than or equal to $7,000. The answer will be less if Weber state total costs are less than 7,000. All right? In this case, mu naught, the cutoff point, is equal to 7,000. Now let's do C. In this case, we have different than and 4%. And what are we asking about here? Now we're asking about the true average returns for my diversified portfolio. So mu equals true mean returns diversified stock portfolio null alternative mu different than. How do we say different than in math? Well, we say not equal to 4%, 0.04, equal to 4.4%. The null always includes equality. If the null hypothesis is true, that means that true mean returns of a diversified stock portfolio are the same as or equal to 4%. If that's true, the answer to this question is no. So that's the null hypothesis. On the other hand, if they're different than or not equal to 4%, then the answer to that question is yes, and the alternative hypothesis right here is true. Mu naught, in this case, equals 4% or 0.04, depending on how you want to write it. So we've covered actually every possible case that's going to come around in hypothesis testing, not just simple hypothesis testing. These will also be the 3 cases for more advanced hypothesis testing. So in the first one, we have a... We have a greater than or equal to and a... Why? I don't know how to make that go away. Oh yeah, there it goes. So in the first one, oh, but this disappeared, of course. So let's get that back. This was 4%, 0.04. So in this first one, the null is less than or equal to, which is a no answer, and then greater than, which is the opposite. That's one case where your null hypothesis is a less than or equal to, and your alternative hypothesis is greater than. The next case is just the opposite, where your null hypothesis is greater than or equal to, and the alternative hypothesis is a less than, because they're always opposite. And notice in both cases, the null hypothesis has the equality part, the or equal to part. The last case is if you get a different than question or something like that, then the null is that they will be equal, and the alternative is that they will be not equal. So notice, again, even in that case, the null hypothesis always has equality. So those are the 3 cases for setting up hypotheses. 3 different types of research questions associated with these 3 different types of setting up the hypotheses. All right? So I'll share these notes with you along with the video, and I'll see you guys next time.